Good morning, everyone. Welcome to another episode of Xa Talk Show. Today we are going to do Wolfram language Mathematica. So this is about an hour, and I'm going to just code Wolfram language. And before we begin, let me mention. So we have this from a friend in Xa Discord, Hekabena. So here is Xa TV in virtual life. Okay, that's interesting. So virtual life is becoming more popular again, and I'm probably going to start to get into Second Life again. So Second Life, it's amazing word. Second Life, you have all sort of things going on in Second Life. Okay, but today we are going to code Wolfram language. Okay, and today we are going to code Wolfram language. We are going to do find and replace. So let me show you. So let's see what else here. So you are looking at my keyboard. This is Kinesis Advantage 2. And then above it is Ultimate Hacking Keyboard. So I have reviews here, detailed reviews. Go buy them. So today we are going to code Wolfram language. So let's start. Wolfram desktop. Okay, where is it? So Wolfram desktop, new notebooks. So 1 plus 1, evaluate 2, fantastic. Okay, so let's magnify and put it here. And we are going to write a find and replace script in Wolfram language or Wolfram script. Okay, so if you don't know, so I have a full tutorial. Just go to search for Xa Wolfram language. So here I give you an introduction where to download it for free. What is the difference between Wolfram language? Download it for free, or you can buy a Raspberry Pi. It comes with it free. It's free for personal use. Read their agreement and whatever. And then I tell you what's the difference between Wolfram language, Mathematica, Wolfram engine, Wolfram script. What's the differences. What it's kind of confusing. So here, then I have a Wolfram language Emacs Wolfram mod, Xa Wolfram mod, for coding Wolfram language in Emacs. You can pay me and buy it, get it. Okay, so then I give you a tutorial, one of the best tutorial about Wolfram language syntax and Wolfram language tutorial. I've done about 10 or more than 10 videos on Wolfram language, so you should check it out. So then Wolfram script, so this is one of my video on Wolfram script. So today we are going to write find and replace script. So let me show you what that is. So if you have comment and questions, post it, okay, about Wolfram language. Welcome, guys. So I have written, find and replace is one of the things I do all the time, like doing, thousands of files, about 10,000, 20,000 HTML files, find replace every day, about few times a week for the past 15 years. Find and replace for a few thousand, 10,000 files, about 2 or 3 times a week for the past 15 years. That's what I do. So I have find replace script written in Python. So, and I have a tutorial and code you can find on my website. So, in Python and several, in Python, in Golang, in Perl, in Emacs Lisp, and I did a video about these several times in the past. Just search for it on YouTube. And so find replace. So there's when I have a script for my own use, for example. So all these different languages, but I also have a tutorial. So what does it involve when you want to write a find replace script? By the way, these are all practical for me. So I wrote them because for one thing, when I started to learn the language, I write the tool. The second reason is that since I use this tool so much, so I have different versions in different languages, so and I can also explore, because since I'm interested in programming language features, design, how they, it feels, and so I have in different languages. So what does it take to write a FindReplace script? So you need to know how to traverse a directory, that is, list all files in a directory and its subdirectory. You want to, and also you need to know. So let's go back to talk show, and I forgot to mention, you also need to know. So I have it written out here. How to filter by file extension, file name extension. Okay, so that's another thing you need to know. How to list directories, how to filter files by file name extension. For example, you want to find replace on all HTML files only, or all CSS files only, or JavaScript files, or whatever, Java, whatever. And you need to know how to make how to copy file, in a language, say Python, Golang, Perl, or Lisp. How do you copy a file? Because you need to do that if you want to do backup. You usually, before you do thousands of files, you want to do a backup before you do the find replace, just in case you made a mistake. So you need to know how to copy file, then you need to know how to open a file, how to write to a file, and then you also need to know open file for read, open file for write, and you also need to know how to find and replace a string. Given a string, how to replace certain regular expressions. So each of these are the individual tasks you need to know when writing a FindReplace script in a new language. And that is exactly what I'm going to show you today in Wolfram language. I did a video before, but it's like a few months ago about this. But let's do it again, because each time is different. Okay, so if you have questions and comments, post it, okay? So let's begin. So first of all, how to list directories and subdirectories, okay? So for that question, let's go to, because I have already written a tutorial, so let's use, that's what I typically do, use my own tutorial to remember, as a reference. So list files. So this is how you list files. Okay. So let's begin to code Wolfram language. Let's see how we're gonna do this. So I'm going to start Wolfram language. Then so you are looking at Wolfram language, and you are looking at my let's see, 17. Okay, magnify the font even more. So this is, you are looking at my Wolfram language mod, XR Wolfram language mod. Wait, where is it? Okay, it's hidden. The file name is too long, so the mode line is like hidden there. So this is XR Wolfram language mod. So for example, you can let me demonstrate a few things. Okay, so expand. Okay, x squared plus xy third power, and raise the whole thing to the third power. Comment this out and run the script. Okay, so actually you need to print it. You need to run and print. So look up okay, F9P. So you see the result at the bottom. So over here you can see. So let's go to the message line. So close that. Yeah. So you can see here's the result. And if we do this in notebook, you see that there's a result nicely formatted. So that's Wolfram language. Free. Get it today. Okay, so we demonstrated that, and notebook and the Wolfram language, XR Wolfram mod in Emacs. So we're gonna do. So first of all, so let's focus. Let's get back to list directories and subdirectory files. So this is how you do it. So we are going to write find replace. But before we do, let's create a directory with 1,000 files. Okay. Emacs. Okay, so let's. I'm just going to create a directory. So here's an Emacs manual. So there are two directories, Lisp and Emacs. In Lisp directory, there are 1,000 files. This is Emacs manual. You can download it from the GNU Emacs website. So Emacs directory, you have also about 700 files. So let's copy the. Okay, so let's go to talk show, go here, and copy this Lisp directory recursively. Yes. So we are going to use this as a. Now let's rename the file. Rename it to xtest. Okay. So here's a directory. So close that. Okay. So here's a directory with 1,000 files. So you can see. We are going to do find replace on this directory. Okay, so copy the file path. Okay, close it. Then go back to our code. Where's our code? Okay, here. Yeah, go back to our code. So in this directory, okay. It's kind of big directory. Let's hold on a second. So let's move them up. Xali info. Okay, so move it here. So rename it XX test. Okay, so here's it. Okay, copy the file path, close, and paste it. Now it's shorter, it's better. So this is how you get the file names. You want to find all files in all HTML files in this file path, directory path. Okay, run it. It's 1,000 files. Okay, you need to show the output. So let's call a different command. So there it is. That's all the files. So now it's hard to read because everything is in a single line. So let's call a command xar space to new line. Okay, so that makes each space you separate it into a new line. So this is how you. So you can see 1,000 files. So let's turn on global highline mode so you can see where my cursor is. So you see 1,000 files. So this is how you list all files in a directory. Okay, and you want to know the documentation, just press a key in XR Emacs, XR Wolfram mod. You can press a key. You can see here's the documentation for the file names function of Wolfram language. Let's turn on JavaScript. Okay, so that's how you list all directories. Oh, and you want to give another option. You want to give another option that is the depth. So usually you say infinity. Okay. Infinity. Okay. So so that means like in Unix jargon, it's called recursion. Okay. So all directories. Okay. So that's one thing. So next, what is the next task we want to solve? Okay. So this is how you traverse directory. So let's move that up. Let's put that. So there is our code, and let's add syntax coloring. Go back to browser, refresh, there it is. This is how you traverse directory. What's the next? How to filter a file by file name extension. There it is. We know how to do that. How to copy a file, okay? How do we copy a file? So I don't know offhand, but we can just try it here. Copy file, there it is. Okay, so file copy, so this is how you do it. Okay, so let's look at the documentation. This is how you copy a file. Copy file, file path 1, file path 2. Okay, and the file path can be remote as well. That's the power of Wolfram language. Okay, and the file path can also be a URL, online website. So, instead of the Unix CP, then you have to use, what is it, SCP and other, commands or rsync or whatever. So, Wolfram language, one of the design of Wolfram language is that a function maximizes what the function name, all possible things the function name is fit to do. For example, copy file, so any URL is also considered file. That's what, anyway, that's a digression. That's one of the Wolfram language design principle. So a function usually have options to do all possible things related to the function name copy file. So it's not just copy file for the current local machine, but it can be URL and so on. So anyway, so for our purposes, all we need is let's remove the syntax coloring. And by the way, the pink window shows all my Emacs command line command calls and the key stroke I press. Okay, so copy file. So yeah, so okay, so we want to copy file. So let's create a new one. Copy file. Okay, so you need to give two paths. So let's for example, let's go to the Lisp sample file. So copy file needs 2 arguments. So this is 1, this is the second. So let's say name it 2. Okay, so if we run it, then we'll see a new file here. We should, okay, run it. Okay, a warning, comma encountered with no adjacent expression. Oh, error. So Wolfram language does not allow the the last comma. So if we refresh, yeah, copy failed. Okay, let's do it again. Okay, done. Shell success. Now refresh, you can see we got a new file, a copy of the file. Okay, so that's how you do copy file. So now next step, get date in ISO format for backup. Okay, so why do we need to get a date? Because when we copy, usually I want the copied file to be named something like this. Okay, let me show you what. So okay, the file path is kind of long, but you can see I wanted to have a date like that, and with a tilde. So that's a Emacs convention for backup file. So you need to generate today's date and usually a time and second as well. So because after a while you have lots of backup files, you don't know which one is formed by what task. So the next thing we need to do is, how do you get the date and in a particular format? Okay, for that question I already have an answer here, Wolfram script tutorial. So let's see, delete the directory, check file existence, date. Okay, get file date. Okay, that's a file date, but we want date time. So so here is how we get date time. Okay, so, but which format do we want? We want let's just say, let's pick a simple one. Okay, so the date will be, let's do in the Wolfram mod. Okay, so get date now. So let's say now date equals to that. Okay, so we don't need that. Okay, run it. So you can see the date is at the bottom output. Okay, can you see it actually? Let's see what. Yeah. Okay, so this is how you get the date. Now let me show you some other variations. Okay, so actually copy the tutorial, go to the talk show, open today's talk show, paste the reference link here, show in browser. Okay, so we have a link here, and we want to date. Yeah, work on the date. So how do you what is this Emacs blog? Okay, so yeah, date, about date. Okay, let's try that one. Okay, run it. Okay, you can see, you know, the second one returns that result. Now usually I want the backup name to have time as well, but however I don't want the colon, because colon is usually a problem in file name systems. On the Mac, for example, colon is actually allowed, but it's, you know, but underneath it has to do a lot of complicated file name conversions, because the Unix file system, you know, in the old Mac file system, HFS plus, it does not, it allows the, you know, okay, so let me explain this. So in the Unix, in the Unix tradition, okay, so in the Mac, in Mac OS tradition, the colon is used as a file separator, you know, analogous to the Unix slash. Okay, so on the Mac OS, you know, in the 1990s, Mac OS Classic, the colon is not allowed in the file name. Now Mac, as far as file system, you know, allowed characters is concerned, Mac is the best between Unix, Mac, and Windows. Mac is just best. It allows the most possible number of characters. Anyway, so I have lots of articles on that. You know, that's kind of history now. But anyway, so Mac switched to Unix with starting around 2001 with Mac OS X. That's Mac OS 10. So now you have the issue where, you know, so Mac before allows the backslash, but now if you are in Unix, you know, you're gonna have problems with backslash. So what the Apple people did is that they did a lot of engineering behind the file name system, so that essentially you get the best of both worlds. But however, so there's some complexity. Anyway, so this is related to file name. Okay, so let's digress and show it. You know, when it comes to Unix, I have 1,000 rants. Okay, so, and I'm not going to turn today's talk show into a Unix rant. Any comments, questions and comments? Okay, I'm gonna read them in a bit. Okay, so I have several articles on file name, okay, because this is one of my concern. Okay, so let me show you one by one. So Unix file name character problem, Unix file name characters problem. This is written in 2006. Unix has 1,000 problems. Okay, that's so. Go to talk show and just log what we talked about. So I'm just gonna paste the link here. So Unix file name characters problem. Okay, Unix is the worst, and Linux inherited it. And here is Rob Pike on the origin of Unix start file names. Start file names is another crap. You know, it litters your directory with a bunch of files irrelevant to you. And it turns out it's a mistake. Okay, Rob Pike explains the history of it. Rob Pike is one of the pioneer, which did a lot contribution to Unix operating system, and he also wrote other operating systems, Plan 9 and so on. And he's also one of the creator of the Golang, which turns out my favorite language, one of my favorite language. So Rob Pike on the range of Unix start file name. Okay, then Unix tar problem, file length truncation, Unicode name support. It's worst fuck possible. You know, Unix. First of all, Unix silently truncate your file names, your files. For example, if you have a directory, you need to move it to another machine, for example, or you need to travel to China or something. So you tar it. But if your file name is too long, more than 120 characters, it silently truncate your files in a tar. So when you expand, you're missing, your file name is no longer the same. It got truncated. Fuck Unix. That's not the only problem. Then you have the Unicode support problem. So if your file name is Chinese characters, for example, you are fucked. Okay, you tie it up, and you put it on USB or whatever. Back then, you put it on a portable disk. Back then you don't have a USB disk yet. Around year 2000. Okay, so you tie up your directory, then you're gonna send it to someone or as a backup. When you untie it, your file names all have gibbish names. Because they are Chinese characters or they contains a arrow or something. It's Unix, the worst fuck up in the computing industry. So this article is written in 2011. Okay, so you got the detail about the why and how. That's a Unix tar problem. GNU tar, more specific, happened to a few tars. Okay, it's the problem is over. It happened to BSD tar. It truncated your file name, because I remember in 1996, around 1996, I was moving a file from 1998 maybe. I was moving a file on IREX, the IREX operating system of the SGI fame, Silicon Graphics, computer, one of the big names in Unix. And when you untie it, it truncated your files. I didn't know. I just found out, it fucked up my files. And Unicode is another reason. Okay, that's about that. Then, so this article is a tutorial on the Unix file permission system. It's another hell, pain in the ass, root wheel, Unix file name permission system, sudo. It's a hack of the hacks. Okay, but this article is just a tutorial telling you what it is. And here is an article. This is a Perl code that check bad file names. File names containing characters that's not allowed typically will fuck up your Unix commands. For example, you have these. Typically you don't want files using these characters. So this is a Perl script that checks your directory, your file names. Okay, this is written in 2009, but I put it up on this page in 2021, so 2009. And this article on Unix file systems case sensitivity, another giant, perpetual, controversial topic. You don't see it much today, but back in 90s or early 2000s, it's a perpetual, perennial topic. Whether file name should be case sensitive or not. And Unix is the worst, okay? Just about everything. When you look into detail, the Unix way is just the worst possible. Because why? Because Unix people, the Unix philosophy, the C language, they don't think. They just, this works. That's it. This works, and it's simple, it's fast. That's it. They never think about problems. Unix file name system case sensitivity issue. This one is written by this guy. Okay, who is that guy? That guy is that guy is an expert of BOS, okay, which was killed by open source Linux around year 2000, BOS. Okay, so we have that, and okay, that's the articles, okay. So showing browser, we have a log of what we talked about. So file name, so we are talking about file name issues. So let's go back to, that's a digression about using slash or colon in file names. So what I was saying is that we want to, I want the backup file name. Hold on a second. Oh, okay, sorry. No sound. Shit. Okay, so okay, so we know how to do string replace. Okay, the next thing we need to do is how to write to a file and read to a file. Okay, so here already, so let's just copy it, write to a file and read to a file. So read and write. Okay, show in browser. So we have all the things we need to do, all the individual tasks on how to write a script to find and replace thousands of files. Now let's put them together. So let's put them together on how to do this. Okay. So is the audio back? I think it's the audio back. Yeah. Sound is fixed. Yeah. So can hear shit. Okay. Chocolate is used for lots of recipes. Okay. Okay. I'm good now. So now let's find and replace strings in a the. So this is a Wolfram language's common syntax. So we are beginning to write this script. So input the. Okay, so input the will equals to okay. So wait. There it is. Okay, input directory and backup, make backup true. Okay. The depth infinity. Okay. So these are the parameters. Date. So input directory, make backup, the depth, find, replace pairs. Okay, so this is going to be a list of find and replace pairs. So we're just going to have one pair. So what kind of word do you want to find? So let's see. Let's open one with a file. Let's say we want to find this string. Okay. Okay. Let's say we want to find this string. So that and replace it by XYZ just for testing purposes. Okay. So this find replace pairs, this script should be able to do find replace on multiple pairs in one shot. Okay, not just the Unix set crap. So this is one pair. Okay, so wait. This is one pair. Let's add another pair. Okay. So let's add another pair. Let's say. Let's expanding. Okay, let's pick some words. Okay, commands. Let's replace all the word commands by X commands. Okay, something like that. And let's do another pair. And this will be something not there. Okay. Like a string, you will not find it, just for testing purposes. Okay, so multiple pairs of find replace pairs, and this can be a regular expression, but we haven't showed how to do that yet. Okay, so let's see what else. So file names. So files, okay, file list equals to file names HTML. So file list equals to get file name extension. Okay, file name. Let's add another variable. Okay, so this is an extension we need to do the find replace with. Okay. Okay, so now we got the file list. Okay, input the depth. Okay, then what else? Then we want to make backup. Okay, we need to open file. So wait, so for each file, so we want to map. Okay, so map a function to file list. Okay, and level 1. Okay, so we want to map a function to all these files, and what this function do, it will first of all back up the file, make a copy, back up the file, then open the file, then do the string replacement, then save the file. Okay, so this is the function. Let's call it process file. Okay, so map this function to this list. Okay, so we have to define process file. Okay, so we have to define process file. Okay, so let me show you how to write a function. Okay, so process file. Okay, so let's write it in the most simple way. You know, Wolfram language has a lot of ways to do things, but for our purposes, let's write it in the most plain, simple way. You know, it doesn't look fancy. You know, if you are doing a demo, you know, in some conference, or you want to something cryptic like the Unix and C people would love, something cryptic. You can't understand the thing, like all the shortcuts, you know. But let's not do that for now. Let's just use the most simple. Anyone who never programmed before can read it and can see what is going on, can understand it. That's one of the power of Wolfram language. As a choice, you can also do it the other way. You can write the Wolfram language using methods such that the result code is more incomprehensible than Perl. I'm telling you that. Okay, because I can show you examples, but how long have I been talking? 44 minutes. Let's not. So Wolfram language, you can write in a way, you can code it in a way, because of the flexibility of the syntax, you can code it in a way such that everything, the entire language is just a nested expression, just like Lisp, like that you see. Purely nested and just function names. So you can understand the whole program by just reading the function names. Okay, or you can write it in a cryptic way, such as this. This is not even cryptic enough. There's more. You can write it in a cryptic way that's even more incomprehensible than Perl. And the thing is that you can press a button to convert either one of these to the other. For example, let me show you. Okay, let's copy that. By the way, I talked about this in one of my videos. The full hour is about the syntax, Wolfram language syntax. So you see, you know, if I evaluate this, what do we get? Okay, it's just a bunch of, you know, a list of lines. Okay, so now if I press a button, let's remove this. You see, I press a button. I have a shortcut, but you know, this is just a shift. Okay, let me shift control T. Okay, so that's these shortcuts. Okay, input, you know, so I can just press a button and look at how they change. Okay, so traditional form and okay, but you can convert them back to this form. All you have to do is okay, so you want to actually hold. There it is. Did we get it right? Now, because you have to hold the set. Okay, anyway, I talked about this in one of my video before. So that's a bit digression. So let's get back to what are we doing. So we need to write a process file function. Okay, so what the function do? The first argument is a list of variables. Okay, the second argument is what the function will actually do. So the function, what we'll do is we'll take one argument, file name. Okay, then do whatever. Okay, let's say 3 for now. So you'll take a file name. Okay, then it will open the file. Okay, let's back up first. Open the file. Do string replacement. Save file. Okay, that's what the function will do. So we're gonna write that. So first of all, backup. Okay, so backup is easy. That line. So backup. So you just file name. So this is actually file path. So let's just change it better. Reflect what we are actually doing. So file path. The new file path will need a date. Okay, so you need the date. Okay, so but before we give a date, we want a constant. We want to assign this to a date. Okay, so what we can do is let me show you. Okay, so wait, not modular, module. Okay, so what this do, the function module is analogous to Lisp's let. Okay, so the function module is analogous to Lisp's let. So now I can put this here. So the second argument is what is the body. Okay, so the body will be join string. Okay, string join. Okay, string join 2 arguments. So the first argument will be the file path. The second argument will be the date. Okay, so you can see, can you see this together is the backup name, backup file path name. So before we join, we also want let's look up the documentation for join string. Yeah, so you can have multiple arguments, correct? Okay, so multiple arguments. So now you need, I want a tilde and another tilde here. Okay, so for example, we can run this and you'll see what it does. String join, what? String join, string expected. Oh, we don't, yeah, the file path, of course. The file path is something slash some XYZ, okay? There it is. You see, that's module is a let, like a Lisp's let. It defines local variables. Then here's a list of local variables. Here's the actual body. Okay, so that's that part. Then yeah, so then this this copies the file. Okay, so that's a backup. Now once you do the backup, now you want to open the file. Okay, how do you open the file? Open the file is read string here. Okay, now this is getting big, so actually I need a module here. So let me put the let here. So let me show you what's going on. Okay, okay, so this is the body. Move the whole body to here. Okay, and move the date module. I mean the date variable, local variable there, so you don't need the module here anymore. So module takes two arguments. One is a list of variables. So we have a date there. Then first of all, we do backup. Yeah, so actually this is shrink. Okay, so backup, then open the file. Okay, so opening the file will be, so you need opening file content. Okay, content equals to, so you need a variable content. Let's put it here. So content is actually, we can put the whole content here. So content read the string file path. That's right. Opening file is already open. So now we need to do string replacement. Okay, how do you do that? How do you do that here? String replacement. So we want to replace the string will be here, file content, and what string we want to replace? Well, we need to do a loop, because remember we have a list of strings. Okay, so let's just remove that, make it simpler. So find replace pairs, we need to loop through these pairs of strings. So how do we do that? We need another okay, we need a loop. Okay, so before we do loop, let's make it simpler. Okay, let's just say should we, what's up guys? So am I doing good? So 55 minutes. Okay, it's already an hour, so okay, we're gonna go fast. Okay, so now we need to do a loop through. So usually you use map. Okay, so find replace pairs, that's your list. Okay, and you need to map a function. So the function is gonna be this function. Okay, so the function will do that. So the string replacement. Okay, string replacement. So each one, the first element in the find replace pairs. Okay, so this needs to be a function actually. So Okay, let's write it in a let's write it in a cryptic way. Let's not. So map the function. The function takes one argument. Let's call it x. Okay, so x is a pair in a find and replace. Okay, so x 1, that means the first part of x, that is the find string. Okay, and replaced by x2, that is the replacement string. Okay, so map this function, let's say pair instead of pair. Okay, actually you don't want a map because you want a loop, because once you wait, do you want a map or a loop? Okay, so this is actually getting complex because there's an issue where once you replaced it, should the new replacement, should the next find replace pair be based on anything of the previous new replacement text or not? Usually it shouldn't. But so okay, so it's getting complex. So find replace pair. So first pair, last pair function. So if we do a map, no, we don't want the map, because map just returns a list of the new contents for each of the replacements. So you want a recursion instead. You want a recursion or a loop. So that, okay, so let's just do recursion then. So let's, okay, so nest. Okay, so nest is the function to call when you want recursion. So nest, 2 arguments. The first argument is a function. Okay, so let's grab it. Okay, the first argument is a function. Then the second argument is the beginning argument. Okay, so if we do nest, then we have a problem of how do you get the pairs. Okay, it's more and more problems. Yeah, okay, so for example, I can show you what nest does. Okay, so if you say nest f2, then 10, it'll just nest f with the first argument of x, then 10 times, for example. That's what happens with next. So nest. So nest is kind of what we want. But however, in this nesting, we need to get the pairs. For each iteration, we need to get that. And how do you... So what you want is... Okay, so let's think about this issue. So you want a function that essentially recurses, but each time you want to get one of the pairs. So some sort of map and nest together. So there's tons of functions in Wolfram language for this kind of thing. Nest while, and there are so many ways to write it. we can do the dummy way or fold. Okay, fold is what we want. That's right, fold is what we want. Okay, fold. Now fold in JavaScript, for example, it's called reduce. In JavaScript, in Python, it's called reduce. You are familiar with that. Okay, let's write fold. So fold 3 arguments fx list. Okay, so the list is just find replace pairs, and the starting argument is, we don't need the starting argument, just take it from the pairs. Okay, then the function, right, the function is this one. Okay, so you see Wolfram language is kind of, you can see it's all nesting, so it's a bit hard to read. But however, for example, if you paste this, for example, let's make this one line. If you paste this in the notebook, it formatted for you automatically. You see the truncation and syntax clearing and all that, you see. And this is intelligent formatting. You see how they wrap the lines at the proper place. So you can see you are calling fold, and you have 2 arguments. So the first argument is a function. Now the function is again broken into 2 lines. Now depending on how wide is your screen, it format them in a sensible way. You see? Okay, so and this not just work for plain text, it also works for complicated expressions such as this one. Well, including when there's radicals, anyway, square roots and so on. So anyway, so let's get back to this. So fold is what we want. Okay, so fold the function. Okay, so here the function takes one argument, which is pair, and yeah, that should do it. Oh, the function also each time, no, this is incorrect. Each time it needs to write the new content to after it does a replacement, it needs to write to the content. Okay, so this is the do string replacement part. Then save the file. Okay, save the file is simple. Save the file is just that. So write string. So why is there 2 arguments? So what's the second argument for? File and string. Oh, file path and string. Okay, easy. So the string is the content, the file path is just that. Okay. Okay, so I believe this is a complete program to do this. Now let's remove these comments. Okay, so let's copy the whole thing. I mean, we can run this. We can try to run this in Emacs, or we can run it in the Wolfram notebook. So let's try to run in Wolfram notebook. Copy or paste, because it looks good here. So here's the whole program. Praise to God, it works. Let's put some comma here. Comma. So once we do this, so process file is a function. Then here is the main. Map process file to the file list. Okay, file list is here. Praise to the Lord, it works. This is the demo, the mother of all demo. Okay. Part spec is longer than depth of object. That means here new string replace. Okay, we got some kind of, we got a empty comma something. Oh, here, yeah. So yeah, you see, it's trying to, it's interpret these two lines as a multiplication, you see, because we are missing, you see, we are missing a semicolon here. Semicolon, okay, there it is. Do it cannot override existing file. Copy file cannot override existing file. So what's going on? So copy file, file path. Wait, which part is destination? Which part is the target? Copies from the local, remote, or cloud file, file 1 to the remote cloud file 2. Okay, so the first is a source. The second is the destination, the target. And here we have string join file path. String join file path. Yeah, string join, and now date, and that should be right. So copy file cannot override existing file. Oh, I think that's a Windows problem. Because in Windows, once you have a file open, wait, what is this? Yeah, that's right. That's what happened. I think, in Windows, once you have a file open, it doesn't let you delete the file. Yeah, so we need to close this in Emacs. I think that's what happens. So let's try it again. Do it. Okay, cannot override existing file. Construct.html. Okay, what's going on? Let's look at the file. Construct. Oh, okay, so this file, what's going on? Open it. Refresh. So you see, it made backup already. You see, all these are backup we made. But why is it cannot override or whatever? Let's switch to HTML mod. Why does it say cannot override? Copy file cannot override existing file. That. Okay, I don't understand. Then part specification is longer than depth of object. Okay, so function pair. So we got, do we have the pair right? So we got 3 pairs in it. This one, that one, and that one. 3 pairs. Okay. String replace pairs. String replace the content by this pair. Wait, we are doing fold. Okay, wait, fold. Oh, remember we are doing fold. Okay, so fold takes the first pair. Wait, fold takes 2 arguments. Okay, so we are okay, yeah, fold. Remember, fold takes 2 arguments. Yeah, the problem is somewhere here. VORNGO. What does that mean? So, question the dude, how hard would it be to use Wolfram language to create geometric patterns like the one found in Persian architecture and actually export the geometry for use in other 3D? It's extremely easy. If you have watched my previous video, you might know. But I can show you. If you just search for Xa Li, math blog, Xa math blog. In fact, I have written a package which one time I demonstrated. So this is a Wolfram language package I wrote in 1997. Why is it so slow? So this package I wrote, it does geometric patterns, probably similar to what you were saying. These were Islamic patterns by mathematical categorization. So you call a function and it can generate these patterns. Then you can export to all possible 3D or 2D software format in existence. Like all if you want to ask the question, which programming language or application that supports the most extensive 3D or 2D formats or movie formats of all software, which software that supports the most? That would be Wolfram language. Okay, so and you can easily verify that. Just search for 3D format. Okay, it'll show you tons, like things you never heard of. So there's a format, built-in symbol, date format, so string format, number format. So you want to, the easiest way is actually you go to the Wolfram language visualization and graphics, import and export. Okay, so you can see import and export. So click on export. So you got this export function, and you can see export format. You can import, export data or sound or files, or there's so many. But what we want to know is, okay, so there's multimedia formats, there's raster image formats, there is, you are looking for 3D formats, right? Something like that, 3D or 2D, like AutoCAD and things like that. There's just so many. So, for example, here's the multimedia formats, okay? MP4, AVI, FLV, QuickTime, Matroska, OGG, and so on. Actually, I think there's more. There's more. Raster image format, okay? So, for example, click on that. So here is, raster image format. All possible formats in human history is here. But we are looking for, okay, so this is, again, so this is my package that does what you are asking. This is, but you don't have to, if you are doing, this package has many features, but you can just code it using built-in functions for the basic things. So you are looking for, so there's a vector and graphics format. Oh, there it is. So SVG, DXF, AutoCAD, EPS, PostScript, PDF, but there's more. Okay, so you are looking for example, 3D printing format. Okay, so there it is. 3D geometry. Open that. 3D geometry and modeling format. So PLY, DAE, OFF. I don't know. Collada. There you have it. So you can export to them. Just call the export function. Okay, so I kind of digressed, and we actually haven't finished this problem. Right now the problem is this fold, and we are already over 80 minutes, 70 minutes. So Does that answer your question? The dude. So how many people are watching? Probably. Yeah, fantastic. So you know, so we haven't actually finished this task, you know, and I wanna I'm gonna chicken out, you know, they always didn't finish the problem. But so there's a little problem that's not working. So the problem is fold. So you know, the problem is really because I didn't think through. So fold, you take the first element. So fold takes two arguments. Yeah, so that is why I'm wrong. Fold takes, the function takes two arguments. Yeah, because each time you need to, yeah, you know, that's why it's called reduce, kind of. So the argument, yeah, so two argument. The first argument would be, the second argument would be content, okay? Wait, the content should be the first argument. Okay, so we need to add, this is the first argument, we need to add content here. Okay, I think. Yep, let's try it. Okay, it's got problems. Now I don't understand why cannot overwrite existing file. Why is this? Refresh, open it, open all these backup files we made. First of all, delete them, okay? Let's just delete them. Now cancel. Okay, it's still running. Cancel evaluation. Alt dot. Okay, so do it. Cannot assign to raw object. String replace. Okay. Alt dot. So we got cannot assign. So we got the function. We got the function that takes two arguments, content and pair. And the function so this is the body of the function. Now, oh, okay, so you don't want to assign it. That's right. Okay, so let's just try it, okay? Okay, for some reason, once the Wolfram language generates the backup, somehow it creates a permission so that you cannot override it again. And this is actually screwed up. This is not what you see. This is, oh, this is error. So wait, let's open the original. You know, I think, okay, so cancel. So actually, I think I screwed up the file. Let's open a small one. Let's, you know, yeah, because you see, it doesn't look like this before. Somehow it got screwed up. You see, I think it just repeated the content. So actually we're gonna do this again. So close that, go up a directory, actually open it, delete all backup, delete all files in this directory. Okay, delete, yes. What? Deletion failed. Okay, why is that failed? Delete. Do it, yes. Permission denied. Okay, so I know what's the problem. So if you open the directory, so somehow when Wolfram language writes to the file, it changed the permission so that it cannot be written to again for some reason. So for example, now can we delete them? You see, the action cannot be completed because the file is open in Wolfram kernel. Okay, that's why. Okay, so let's restart Wolfram. Quit kernel local. Quit, yes. Okay, then go back to Emacs. Delete this file, yes. Okay, done. Select all. Delete. Yes, delete all. Done. Okay, and it's, wait, what? Permission denied. What? Delete. Why is permission denied? I don't get it. Delete, yes. Delete, yes. Select all. Delete, yes. Oh, it works. It worked. Okay, now you go to Emacs blog and copy the manual here again. Open this, select all, copy. So now we have a fresh copy of Emacs this manual. Okay, and now we can try our find replace again. Okay, so now let's run this code. Do it. Okay, I think this error, we are fucking it up. Oh, okay, no, so okay. So now let's look. Okay, so let's check if our code works correctly. So initial, there shouldn't be any word containing initial, but however there it is, so it's not correct. What about the word command? Search for the word command in this directory. Okay, so there's a lot of occurrences of the word command, so our script actually is not working correctly. So debug, more debug. Okay, but I think that's it for today. Ksa, you are my inspiration and idol. Thank you. Okay, but so if you guys like my stuff, pay me. Okay, that is actually, what makes, that's what makes the world go around. So if you like my video, buy me a drink. Okay, and that's it for today. So you Russian people, what is this abbreviation? Please show hair, sir. What kind of... Okay, that's it for today. Thank you guys for watching. Bye. Shutting down in 2 minutes. 2 minutes. So this, but we didn't do it successfully. That's a bummer. That's not right. So we need to fix this. Oh, right. That's right. We didn't actually write to content. That's right. We didn't write to the content. That's right. So okay. So let's try this. So the function. Okay. So content equals to. That's there. Do it. Cannot override existing again. So basically, once Wolfram language writes to the file, there's a permission problem. So let's solve this problem. Once the Wolfram language writes to the file, somehow it made it so that you cannot modify it again. Oh, you have to close file? Let's see. Yeah. Bye guys. Bye. Delete. Delete. Cannot write to file. So stop kernel, quit kernel, local, quit, delete them. Okay, now this time let's not copy the whole thing. Let's just copy some of them. Okay, so now let's redo this all over again. Okay, now this time it should work. Refresh, open, search for init. Yeah, it worked. So this is great. So finally we are successful. You see, because you see in our code we want to replace any word initial to XYZ. So there it is, XYZ. And we want to replace the word commands by X commands. Okay, so let's search for the word commands in this directory. Let's see if it's there. You see, now we have X commands. You see, open it, you can see right there. So fantastic, success. Thank you guys for watching. Bye. So now we just copy this, make it plain text. Okay, copy it, go back to Ksa Talk Show, and add the code there, and that's it. We are successful. So yeah, open this file, put it here. You see, Wolfram language formatted for you. So this actually, yeah, I don't want that. Okay, so there it is. There it is. Color it, show in browser, and here is today's result. Find replace strings, multiple pairs in Wolfram language. Bye guys.